Thank you very much. So I'm going to tell you a bit about choosing a network protocol. So first, who am I? My name is Olivier Crête. I've been doing open source for over 20 years now. It's pretty scary. And I've been doing multimedia stuff at Collabora since 2007. So that's also been a very, very long time. And I did a couple years of doing video calls, which is really video streaming over the internet in two directions, right? And then I kind of evolved into doing a lot of random multimedia stuff. And so this is why I kind of have a lot of media streaming experience. There are quite a few network streaming protocols. This list here is just the ones that GStreamer implements. Although it's a pretty extensive list, there are some other protocols, but these are kind of the top 20 that people actually use or have used in the last 15 to 20 years. And people often come to us as consultants and they say, I would like to use this protocol to do this. And I'm like, no, this is not the right choice. This will not give you what you want. What you want instead is this or it's that because of this and this constraint. And a lot of people are confused because there's so many, and in many ways, they'll do exactly the same thing. They get video from point A to point B, but not exactly the same way with not the same constraints. And so in this talk, I'm going to try to tell you a bit of a framework on how to select the right one. And so basically, there's two axes on this framework. The main axis is latency versus reliability. So in most video streaming systems, the idea is that either you can get the image really quickly or you can get perfect quality because you wait for a long time and then you can do retransmissions or all kinds of mechanisms to correct any transmission problem. Right? If you display it immediately, you don't have so much time to correct. So that is kind of the main one. The second one is adaptivity. So adaptivity means can you adapt the stream, the characteristics of the stream to the network or to the devices? The most common factor is bitstream, obviously, bitrate, formats, but also sometimes you think like the resolution. If your TV is not a 4K TV, there's no point in sending a 4K stream, even if you have a really fast network. And this adaptivity can happen either by the receiver or at the sender, right, the client or the server. So starting with low latency protocols. First, there's like the super low latency protocols that are so low latency that they've been designed only to run on a local network. The most popular of these protocols is probably something called SDI. SDI, it's what basically every TV station runs inside the station to move video. This is what post-production houses use to move live video inside their systems. It's been deployed for a long time. And it's not an IP-based network. It's a specialized system. You buy special cards that you put in your computers to actually access it from a computer. And it works quite well. But it doesn't have the flexibility of IP-based networks. So the SMPTE people have built this new protocol called SMPTE 2110, which is basically raw video over RTP, which provides the same functionality, but using an IP-based network, meaning that you can use Ethernet, you can use what they call IT infrastructure, which just means a normal network. And but this is uncompressed video. So we're talking 10 gigabit streams, right? So you need like 25 gigabit Ethernet if you want to have more than one stream, or this kind of very big infrastructure. And it means that you cannot send it using the Linux TCP IP stack because it's just too slow. So either you do user space networking, or what a lot of people do is that you actually buy a card that you just give it a whole frame and it does all of the IP packets for you in hardware, which means an FPGA. So in many ways, this is integrated in the same way as SDI. There's also AVB, which is not an IP-based protocol, which is an Ethernet protocol. It's a layer 2 protocol. And the kind of big feature is, it has a lot of features, but the one that I think is differentiating is It has a system to reserve bandwidth throughout the network so that you can have guaranteed delivery. It's used in some application in cars. There's some use of that. So to send like the audio streams from like the front seat to the back seat and things like that, or to send the video stream from the decoder, which might be in the driver's console, to the back seat where the children are. Next ones is RTP-based systems. So a lot of low latency systems are based on RTP. RTP is really simple. It's a 12-byte header that you put in UDP packets. It has very little information. It has, a timestamp, a sequence number, a packet type, and a couple of flags. That's it, right? There's very little in there. It's widely used. One of the ones that's used for local networks is, but RTP, the packet type is only a small number, right? A number that's, you have like 24 numbers that you can actually use. So you need a description to tell you what this number actually means. And you have to carry this description somehow. So you can do what they call plain RTP, which is you just send the packets and you've just configured the formats on both sides. This is like the old way of doing it. And there's something called RTSP, which is a protocol to exchange a description in a format called SDP. This is what they use for security cameras. So almost all the security cameras that you'll find, like IP cameras that maybe, this is analog, but all the IP security cameras, they actually use RTSP, and it works. But it doesn't go through NATs if you send the video as UDP, so it's a bit limited that way. Something else that you will see in the broadcast world is MPEG transport streams sent over UDP directly with no RTP, and this is a bit annoying because MPEG transport streams were not designed to have any kind of way to recover from reordering. They were designed to send over a satellite feed or a TV network. So it's not that great. You better send it over RTP if you're going to do that. There's something called NDI. Don't use it. It's a proprietary thing as a library, and they're not nice people. Low latency. So these were like very low latency. Like SDI, it's line based. So you can actually have a latency of under a line of pixels. This is like low, but not that low. So SRT is quite popular. It's a system it's UDP based. It's not RTP. It's a library based. So by which it means there's no standard. It's just C++ code. It's open source C++ code, so that's good because you can actually use it. It just works. The API looks like a socket, and it's really meant to transport MPEG transport streams. It provides a guarantee of ordering, but not a guarantee of reliability. So packets can be dropped, but any packets you get will be in the right order. So in theory, it's agnostic and you can send anything, but it was really designed for MPEG transport streams, which was what TV people used. And it was a huge success commercially. There's like 100-something members in the alliance, 50 of which have shipped products already. So people actually use it because in this world, everyone was doing their own solution, and one of the companies said, I'll open source mine, and then everyone adopted it. Then you have a bunch of RTP-based systems. One of them is just sending MPEG transport streams over RTP, which works. But then you don't have retransmissions that SRT has, or forward error correction. But you can have all of these things with RTP too, right? There's RFCs for doing all these things. And there is a group that developed a standard called RIST, where they took some of the RFCs and modified them just to make it slightly incompatible with what everyone else is doing. And publish that as a specification. So there's an open implementation of that in GStreamer. Then you can have SIP, right? So this is a different use case that people don't think of, but it's like a video call, right? SIP is as a calling protocol. There's XMPP Jingle, which is exactly the same thing as SIP, but in XML. But it's one-to-one matching to SIP. And then we exchange an SDP just like RTSP does. and we use that to define what kind of codecs and stuff we'll send, and then we say that as RTP over UDP. So it's like very much the same as RTSP, but bidirectional. WebRTC, it's all the same technologies, but SIP was really, the interrupt was largely done at the idea that you do at the lowest minimum codec, and the worst of all, no retransmission, none of that. This was all kind of proprietary add-ons in the SIP world, or not proprietary, but everyone has their own flavor. WebRTC was an effort by Google to, well, they say all the browsers vendors, but everyone uses the Google implementation. So it's really Google who drives it. And they interrupt video calls at a higher level. So there's retransmissions, there's adaptivity, there's all the things that you would want. And Google also are nice people, so they force everyone to use open codecs, right? VP8, VP9, H.264 if you really must, Opus for audio. So that's really good. But it's complex. It has all of this legacy that works, but it's not trivial to implement, which is why really there's only one implementation that is complete, which is the one that's from Chrome, that Firefox just adapted the library. The only almost complete implementation, other implementation that I know is GStreamers. And it's big and non-trivial. And then your application needs to be complex too, which is a bit annoying. Next, medium latency. So that's 1 to 10 seconds. One of the things that you can get once you get there is large scalability. So using a CDN. This is basically so you can have broadcast. This kind of is a bit kind of the next level, right? Means TCP, not UDP anymore. There's some specialized systems, and there's some legacy ones too. So CDN scalable. One of the things that you do with CDNs, all of these other previous protocols, all the adaptivity was always done at the sender side, or none, right? If you have very low latency, you don't adapt. If you have medium, low but not that low, you do the adaptivity at the sender. But if you want to have scalability, that much scalability, you need to have the clients do it, because if you have millions of receivers, the servers cannot adapt. It gets way too costly. So there's two protocols. They're very similar but different to make it exciting. Low latency Dash and low latency HLS. So both of them work the same way. You have a manifest. In Dash, it's an XML. In HLS, it's an playlist type file. And they tell you which files to download. And each file is a very short video file. And basically, you download all of these files and you play them back one after the other, and you get a stream. But for each of these segments, you can have different bit rates or different resolutions. And the client can pick which one it wants based on its evaluation of the bandwidth. So the client has a lot of flexibility of how to implement it. Browsers support HLS natively because the original iPhone did, and it was the only way to send video. Most people now implemented all of this in JavaScript anyway, right? So there's JavaScript things to play all of these formats. I should also mention, so what's low latency? So these formats originally had 30-second latency. They had 10-second long files, and you would have to download 3, and you would have to be a bit before, because if you play too fast, then you'll get a 4.4. Low latency, one of the big things is that you can request a file from the HTTP server before it exists, and then HTTP will just block your request until the file is there, so you can get it almost as fast as it's being produced, which means that it's now low latency enough that you can have sports, because people like to bet on sports, and so latency matters for some reason. So that's one of the big ones. Next, we have what I would call pushed over TCP. So it's not pulled like HTTP is. Really, you connect to a socket, and the server sends you some data. RTSP, TCP. So RTSP with UDP for video. since the video goes from the server to the client, that doesn't work with NATs because the client doesn't open ports. It's a pain. One of the things that you can do is just send the video over the control connection. That's a bit less scalable, but it's more well used than you think. A lot of consumer-grade security cameras where you have like an iPhone app, they actually just open a tunnel and then send it over RTSP, TCP. Uploading to cloud streaming. So that's another use case, right? You do things like YouTube Live or Facebook Live, and you want to send. Use a protocol called RTMP. So RTMP comes from Flash. It's actually a remote procedure call protocol, but there is one application inside of it that everyone implements. That was the Adobe Media Server, as it was called. And this is basically what everyone calls RTMP. And they have their own video format in there called FLV. And that is a bit like my first video format. It has one video stream, one audio stream, no more than that. So people have made all kinds of extensions. If you want to send multiple languages, you open multiple connections, and then the application layer has something to say, oh, I know that this is like the other audio from this first video, and I have to resynchronize them. So it's in a way, it's very primitive. Since it's pushed over TCP, there's no drops, meaning that you have to have relatively high latency to not have any problems. People have been pushing SRT as a replacement for that, but it's still like dominant for everything on the internet, sadly, for any what they call contribution, which is sending from you to the service. And then there's internet radio. That's a huge one. Lots of people use it, and this is using something called HTTP streaming or shoutcast or icecast, which is basically you make an HTTP connection. And the server says, I'm sending you a file, but it's not really sending you a file. It's sending you a file with no end, like a live stream. And in theory, there's icecast where you send an OGG container, but the most common thing is just to send a plain MP3 stream. And this is internet radio, right? As most of us use it. Well, specialized. So I'm using VLC as an example, because this is the one that GStreamer has natively, but there's a couple more of these protocols. And people say, well, this is a remote control protocol, but really you're receiving a video stream and sending some control information, like where my pointer is and some letters from the keyboard. So remote desktop is, it's a video sharing protocol, video transmission. Some of them, like VNC, mostly uses JPEG. So the compression is not that great, but the idea is that you don't send that many frames per second. They have features like damage, so you only send the part of the image that has changed, like the rectangle. And since it's created from a computer, you know exactly. You don't have to actually look at the video. You know what's going to change. And then there's a bunch of legacy in this bit of the world. So Real Player had its own format based on RTSP, but not using RTP. Microsoft has its own format called MMS. That's still supported in Windows Media Player and GStreamer, but I hope no server still does that. Then higher latency. So there's the two main ones. These are like 30-second kind of range. MPEG- and HLS, but the original system. And this was like for everyone. HLS was the only way to send video to an Apple TV, so everyone uses it. Sadly now in TV. So as I'm right on time, I have time for some questions. Maybe the internet.
We have lots of questions. Number one question is: do you think there will ever be an independent implementation of SRT?
That's a very good question. I know some guys who said we only implement protocols that we can implement ourselves, and we're going to implement SRT. And then 6 months later, I saw them and said, well, we use the library instead. Right now, I think there will be at some point, but not in the short term, because the protocol is really C++ defined.
Which protocol would you use to re-implement Netflix?
So the answer is exactly what Netflix are doing right now, which is something that looks like Dash or HLS. And it's basically the right way to do it.
What protocol is best suited for video editing over the internet?
So it depends what you mean by video editing, right? Over the internet, that's a complex topic. So video editing, you can do basically like a live, you can do all the editing on the server and that your client just be a live view of the server. Then you want real latency, you want WebRTC. Or you can do all the video editing in the client in JavaScript. Then you just download files and just play them back, right? So it's not actually a stream protocol. So there's like different ways. It really depends what you're trying to achieve.
And what about RIST or Dante AV? I think the question was at the beginning of your talk.
So RIST, I talked about RIST, right? It's basically RTP. Dante, I'm not going to talk about it because it's a hardware-defined protocol. You buy the hardware from one company, and you put the same hardware at both ends, and it works, right? So, but there's no open implementation. There's no standard. That's just you buy little secret chips. Yes, I mean, in secret, there's no great secret. There's just audio over IP, right? There's no magic there, but don't.
What FOSS, RTSP plus RTP server open source solution would you recommend?
So there are a bunch of RTP and RTSP servers are there. So RTP stacks, I'm a GStreamer guy. I will tell you the GStreamer RTP implementation is actually probably one of the most complete and complex. Like Live 555 is quite popular in the RTSP world. There's others. I mean, RTP is not that hard, right? So,
is there a viable peer-to-peer protocol?
I don't believe in peer-to-peer. Next question. So, well, WebRTC is designed for peer-to-peer, right? That has all of the ICE things to create peer-to-peer connections. But in practice, we noticed that people actually send it through a cloud server. So, in practice, peer-to-peer is not as useful as we would think it is. Am I missing one?
Isn't there a licensing issue with HLS where you have to pay if you implement a receiver?
As far as I know, no, because HLS literally is just a web client, right? There's nothing there. And the transport stream, which are now out of patent.
Do we care about IPv6 nowadays?
All of these things work.
It's a troll, but
I hope not. It works here, though. I'm surprised.
it works, yeah. What are your thoughts in the LL-HLS, low latency HLS versus DAS-CMAF low latency battle?
I don't have great thoughts about this. It's all the same to me.
All the same?
It's all the same, really.
Do you think we will need new protocols to support new applications, such as link aggregation, using 4G and Wi-Fi at the same time?
I have no idea.
That's supported by RIST.
Yes, it's supported by anything that can do more than one IP stream, right? SRT also has it now.
Okay, any question from the floor? Yep.
Yeah, so you mentioned with SRT that it's basically like a pipe people set up, but you have to imply that you have to have a port open ahead of time, you know which port you're sending to. Have people implemented signaling protocols on top of that, like RTSP style?
So, yes, no, not really. Yes, sorry, yes. So I mentioned that SRT, you have select a port and then you send it to there. So there's not really like something like RTSP where you can negotiate that, but you can multiplex multiple streams over the same port. So basically, you just have to open one port and then everyone can use the same. And there's now a specification in SRT where you can send a string at the start, like which they've defined to be JSON, and then you can have like metadata about the stream. So you can say, I'm saying a stream, but this is the stream. Like here's like my username and password, for example. So you can do authentication. So that's how they do it.
Cornish?
The reason you didn't mention multipath JPEG as a legacy protocol?
No.
Can you repeat the question, please?
Is there any reason where I did not mention multipath or motion JPEG? No, I completely forgot about it.
Yes.
streaming, do you think SRT is feasible or is
So for real-time, like very low latency, like video games, in this case, SRT is really designed around transport streams. So it's not, it's what TV people call low latency, which is like 1 second. So if you want really real-time like video games, then you need RDP type features and clever encoding tricks maybe too.
something to build on RTP, not RTP?
Yes, I think so, yeah.
Maxime?
Do you know what Twitch use for live streaming? Because it's very low latency.
Do I know what Twitch uses? Their client is Flash-based still, I think. No. It's not anymore?
They do HLS.
They must do HLS, right? Because yes, yeah. But yeah. So he was saying that Twitch, they have their own. It's like HLS, but not really, because they write everything their own. And this is what all of the big guys do on the web, right? All of the Netflix of the world. It's like something that looks either like HLS or like Dash, but that they've hacked up to do whatever they need.
Last question.
And last year there was a sports event in my country. They implemented RTMP for live streaming of the sports events. When you open the web page, you have one URL. But when I check the each individual package, video packets, it changes URL. So like you have like 15 minutes of one video, and after that there's another URL, increments by one. So is that the correct way of implementing protocol?
RTMP, you said?
Yeah.
So the question basically is, there's some systems that you get a stream from one URL, and after some time you just get a different URL, and that is actually very common, especially when you, let's say, add an ad in the middle, right? So you might actually have some video and then put a different video and switch the URLs. This is a bit like what HLS does, but you don't have to do it as often as HLS, right? This is a pretty common way of doing things.
Like 3 hours, but still.
Yeah, that's a common way of doing it.
Thank you, Olivier.
Thank you.